Today we're going to do special right triangles. And the thing about this is your first time seeing them, I believe. I don't believe you've had them in any other curriculum. But you are going to have them next year in Algebra 2. You're going to have them in pre-calculus. Every other math class from now on, they're going to assume that you know these two special right triangles. So that's why I'm going to take just a little bit of an extra moment to share them with you. So the first thing I'm going to do is show you where this one comes from. It looks like a square, right? Hopefully everybody's got that. Here we go. This is a square. So all of these sides are equal. And the other thing we know about squares is that they all have right angles. So that's kind of cool. Now, what I'm going to do with this square is I'm going to cut it directly in half on the diagonal. Of course, I shouldn't be eyeballing this like that. If I tell you that this side is like, say, 1, and this side is 1, then you can figure out what this side is here. Okay? If I had sides of 1, since we did Pythagorean Theorem yesterday, I know it would be 1 squared plus 1 squared equals x squared, because that's my hypotenuse. So then I know this would give me 1, and this would give me 1. So 2 equals x squared. Well, I can solve that too. I'm going to undo my square with a square root. And so I get x equals the square root of 2. So that means if this is 1 and this is 1, then this is the square root of 2. Well, the beautiful thing about this is that if this is 10 and this is 10, then this is 10 times the root of 2. Or if this is 17 and this is 17, then this is the 17 times the root of 2. We've talked about similar triangles already before. And so these are in this proportion that if this is x and this is x, not the greatest, but if this is x and this is x, then this is the root 2 times x. Or oftentimes what we'll do is put it in front to make sure it's not there. And then the name of this triangle, we always call it the same thing, is because these are all right angles, but you know that diagonals bisect those angles. So half of 90 degrees is 45. So that makes this triangle here a 45, 45, 90. And the sides are always in this proportion. And here's what it looks like. I just did a really big one there. So it's called a 45, 45, 90. Of course, you can turn it and stuff, but they're always this way. The legs are always the same because it's half a square. And then this one is always going to be that same leg times the square root of 2. So this right here is 45, 45, 90. Do I have any questions right now about it? Okay. I'm hoping you all got that. What we're going to do now is a number of problems, okay? So now that we know where it comes from, we're going to fill in this here in our notes, and then we'll do these problems, and you'll see how lovely this is. It's just, they're super handy, okay? So you can see my objective for you is that students will be able to find side lengths of special right triangles. This is the first one, the other one's on the back. In a 45, 45, 90 triangle, the hypotenuse, remember that's always across from here, is the root of 2 times as long as each leg. So I'm going to have you mark this up. If this side is x and this side is x, then this is x times the root of 2. So like if you want to think of it this way, the hypotenuse here is equal to the leg times the root of 2. That's just one way. It might help you to think of that because of the work we already did before. So here's how you do the problems. Find the value of x. Well, this leg is 8. That means this leg is 8. And so if I want to find x, this is upside down, right? But if it were facing that direction, and x is the hypotenuse, x is 8 times the square root of 2. Because it's equal to the leg times the square root of 2. Now, if you did the Pythagorean theorem like we did earlier, you'd still get the same thing, but we can use this ratio here, the x, and the x root 2, to just go straight to the answer. Here's b. This side is x, this side is x, so those are our legs. And this says 5 root 2. So because this is x root 2, that means that here x is 5. It's just the number in front of the root 2. As always, if you have a question, or if I go too fast, please raise your hand. Or unmute yourself. Now, when I get to C over here, this example is slightly different because I'm looking for the legs, but this hypotenuse does not have a root 2 in it. Okay? So I'm going to look back over here. The hypotenuse is equal to the leg times the square root of 2. So that means that 9 is equal to x times the square root of 2. X is what I'm looking for. Well, in something like this, I'm going to divide both sides by root 2, which is why we reviewed, right, that proficiency. Yesterday we did a bunch of these. So these will cancel, so I just get x on this side, but I can't leave a radical in the denominator. So I'm going to rationalize it by multiplying times the equivalent of 1. Then the top of this becomes 9 times the root of 2. The bottom of it is root 2 times root 2 is root 4, and root 4 is 2. Just becomes 9 times the root of 2 over 2. Okay, again, questions? So I've shown you some examples here. Now I'm going to ask for you to volunteer. See if you get it. Here's number 1. This leg is 8. It's a 45, 45, 90. That means this leg is 8, but what is x? Somebody take a guess at it. What is x? Go ahead and unmute yourself. I don't see any hands.
8 square root of 2.
Yeah, thank you. And that's all it's going to be, is 8 the square root of 2. Now, for number 2, it's again upside down, but I see that it's a 45, 45, 90. This leg is 14, so that means x is 14 in this picture. And then y is, somebody else tell me. But thank you, Shira. What is y in this picture? Here's your hypotenuse. Your leg is 14, so what is y?
$14 square root of 2.
There you go, 14 square root of 2. That's how we practice. We take a stab at it. Now, this one says the leg is 18. That means this leg is 18. So x is equal to Sienna, what do you think x is? If you were going to do this problem, Sienna, which one would you guess it is? Sienna, can you hear me? Okay, Vincent, I know that you have already done this assignment, so can you tell me what x is?
Hello?
I can hear you now.
Oh, okay. X would be
18 what? Yeah, I'm asking, so here my legs are 18, but you know the hypotenuse is longer, right? How much longer is it?
twice as long?
It's not twice as long. It's, if these are 18, then the hypotenuse is times root 2. So I have 18 here. What is x?
I'm not sure.
All right, let's take a look. Vincent, I'm going to want you to stick with this. These sides are 8, 8, and 8 root 2. These sides are 14, 14, and 14 root 2. Here I have 18, 18, and I'm looking for this side. So if you follow these patterns here, what is x?
Just 18 or 2?
That's it. Exactly right.
Okay.
That's, yeah, I was not asking you something tricky. Okay, very good. Now, this is the part that goes on the other. We have gone over the first special right triangle, and that's it. It's x, x, x root 2. Now we have a second one, so we're going to go over this one. Now, if you have a, let's see, this up, an equilateral triangle. Close enough there. Okay, right? So this is 60, 60, 60. These sides are all the same. We've done these before. We know what they look like. That's an equilateral triangle. I'm going to say that I have sides of 2. Okay, so it's 2, 2, 2. Now, if I want to make a special right triangle, then what I'm going to do is draw a perpendicular straight from the middle. See how that works? This angle is still 60. This angle is 90. What does that make this one up here? This one here, it got split in half. So what's half of 60? I need you guys to be more involved in this because this is your education too, and I know you can answer questions like what's half of 60?
30.
Yep, it's 30. So congratulations, you have just figured out the special right triangle called 30, 60, 90. That's the name of it. Okay, so this is now a 30, 60, 90. If this side is 2, and I have cut this in half perpendicularly, then this side here is 1. Right? 1 and 1. And so if I want to figure out what this altitude is right here, well, this is just a regular old right triangle. So we can use the Pythagorean Theorem. So let's say this is C, for our leg's sake. So it's going to be 1 squared plus C squared equals 2 squared. Then I get 1 plus C squared equals 4. I'm going to take away 1 from both sides. I get C squared equals 3. But then I don't want c squared, I just want c. So I'm going to undo the square root. I'm going to undo the square with a square root, right? Because those things cancel each other out. And I get that c is equal to the square root of 3. Okay, which means over here, this side is 1, this side is 2, and this side here is the root of 3, which sort of makes sense if you think about it here. I want to point something out. This is my smallest angle, and it's across from 1. This number, root 3, is 1.732. If you popped it in your calculator, it's 1.732. So this is my smallest angle, and it's across from the smallest side, 1. This is my biggest angle, and it's across from the biggest side, which is 2. 2 is bigger than root 3. And so since this is 1.7, and it's between 1 and 2, that goes with the angle that's in between 30 and 90. Remember that relationship that we learned about in our last chapter. So the way you keep track of this one, okay, is that the small angle is the 30, it's across from the 1. The 2 is across from your hypotenuse, and the root 3 is across from the 60. So this is where it comes from. This is what it looks like. And you're going to love this. You're going to learn it. You're going to sleep with it. You're going to wake up with it. You're going to absolutely adore this triangle. It is called the 30, 60, 90. Okay, 30, 60, 90 right there. And the sides in proportion are 1, 2 for the hypotenuse, and root 3 for the altitude. So it looks like that. Any questions right now? Okay. So now what we're going to do is go back to our notes, okay? And the back side shows it right here. In a 30, 60, 90 triangle, the hypotenuse is twice as long. Hypotenuse is twice as long as the shorter leg, and the longer leg is root 3 times as long as the shorter leg. So this one's sideways. As you can see, here's my small angle. That's my 30. It's going to be a 1 across from here. Or in this case, let's call this x. So this is x. And then the hypotenuse is twice that much, right? And then the one that's across from them is x times 3. If you want to, you can call this like the longer leg, and this the shorter leg, and this the height for the hypotenuse. So that if you wanted to also, some of you like little formulas, this could be that the longer leg equals the shorter leg times the root of 3, and you could do this one that the hypotenuse is equal to twice the shorter leg. You know, if you want to, if that helps you remember how to do them, absolutely use that for sure. So what we're going to do for each one of these, again, we're going to practice these. I'll show you a few, and then I'll ask you to volunteer. Find the values of x and y. Write your answer in simplest form. So here, 30 is the small one, 60 is the one in the middle, okay, and then this is 9. So I'm looking for x. What I have here is that I already know the longer leg. So if you go like this, you can figure out that 9 is the longer leg. So this is going to be 9 equals the shorter leg, which here is x, times the root of 3. So this 9 is going to equal x times the root of 3. We're going to do the same thing we did before. I'm going to divide both sides by root 3. Then you're going to have to rationalize by root 3 over root 3. So you'll get x equals, now this whole thing turns into a 3. Okay, root 3 times root 3 is root 9 is 3. So 3 goes into 9 3 times, and your final answer is x equals. Okay, so if x equals 3 root 3, okay, we know that the hypotenuse is equal to 2 times x, then the hypotenuse is 2 times 3 root 2, which is, 3 root 3, which is 6 root 3. So once you find that shortest leg, you can figure out the other two very quickly. And also, if you need to, just move your paper like this. Like for me, it helps. It's easier for me to see it if it's straight up and down like this. And the first few, it's going to take you a while. So the 30 is across from 8. Okay. The hypotenuse is always twice this. So here, y is 16. And here, x is 8 times the root of 3. Of course, I probably should have written that straight up and down, but that's how it works. This is your small one. That's twice as much. That's times root 3. We'll practice some more. Again, if it helps you to go like this, then do that with your paper. I'm going to try to do it without switching like that. Okay. The 30 is across from 1/2. So the 1/2 is the smallest. Right? The hypotenuse is twice that. And the y is equal to this times root 3. So this will be root 3 over 2. As simple as that. Number 3. Small angle across from the smallest side, the shortest side. So the hypotenuse is twice as much. And the longer leg is simply this times root 3. So we're going to practice a couple more. Do I have a volunteer for number 4? I've got the shortest side here, that's 12. So this is you being involved in your own learning. Tell me what x is.
24.
Thank you. It's definitely 24. And then y is going to be what? 12 times?
Square root of 3.
That's it. Square root of 3. See, so it's best when you know this one here. So now if you don't know that short side, but you know the longer leg, you still have these little equations here. The longer leg, so 12 is going to equal x root 3. You're going to divide both sides by root 3. Then you're going to rationalize. So on the top you have 12 root 3. On the bottom you have 3. Right, because that turns into root 9, which is 3. So then these are going to cancel to give you 4 root 3. So your x here is 4 root 3. And then your hypotenuse is twice that, so what is y? Twice this would be times 2. It's going to be 8 root 3. Same thing here. The shortest side is across from x. This is going to be x times the root of 3. So 8 equals x times the root of 3. Same process. Let's divide by root 3. And then, of course, you have to rationalize. So x is equal to 8 times the root of 3 over 3. And then y is twice as much. So what's this times 2? Anyone can answer.
16.
18. That's how you do that. There's one other type of problem I want to throw at you, and then we'll be done for today's notes. And that's that you have an area problem. So say you have a road sign, and it's shaped like an equilateral triangle. We're going to estimate the area. Now, all you have to do is use this 30, 60, 90 because this is an equilateral triangle. So we're going to round our answer. But first of all, what I'm going to do is I'm going to redraw this so that it's easier to look at for me. This is my triangle. I'm dropping it halfway. So this long one is 36. This one is 18. So how much is my height going to be? What is my height going to be here? This is 30. This is 60. This is my x. That's my single x, and that's my twice x. So what is this going to be right here? It's not going to be 36 because it's only, so this is a 30, 60, 90, remember? This is the longer leg I'm looking for. So it's going to be the shorter leg times root 3. Shorter legs times root 3. So thank you for volunteering. Try again. This is the shorter leg.
Square root of 3.
Yeah. That's going to be the height. So I'm going to put that number here. I know the base of this triangle is 36. The height's going to be 18 root 3. And really all you need to do is grab your calculator because I'm not going to expect you to know that root 3 is 1.732. All you have to do is go 0.5 times 36 times 18 root of 3. And that gives me 561. It says to do it to the nearest hundredth. So that's closer to 18 than it is to 19. And those are inches squared. So I can have my units. It's very straightforward, and I can see that my area is equal to 561.18 inches squared. So I have assigned you 14 problems. Keep these in front of you.